Welcome to the Sustainability Nugget podcast. I am Rarasu Maraibi.
And I'm Tosin Folorunsho.
On this podcast, we learn about sustainability by discussing various related topics while focusing on three pillars: the economy, the society, and the environment. Hello everyone, welcome back to another episode on the Sustainability Nuggets podcast. Today I'm in Glenmore, Pennsylvania with Janice Kesley, the co-founder of SolarCITIES. Hello Janice.
Hello Rarasu.
Thank you for being on the port today.
It's so great to see you in person.
So today we're going to be learning about small-scale biogas systems while Janice takes us on a tour of the SolarCITIES biogas digesters. So let's jump right into it. Janice, can you just give us a brief background about yourself and your current role?
Well, I'm now a retired teacher. I taught part-time, most of my adult life. And I have been doing small-scale homestead farming ever since we moved here 40 years ago. So I'm interested in teaching. I've worked with international students for many, many years as part of an alternative international exchange program and farming exchange programs. And this is what I do now since I met Thomas H. Culhane, who's a National Geographic explorer and a university professor at the Patel College of Global Sustainability at the University of South Florida. And he also works out of, I met him when he was still at, and he still is, at Mercy College in Dobbs Ferry, New York.
Awesome. Can you provide an overview of SolarCITIES and its mission in promoting small-scale biogas production as a sustainable solution?
Yeah, sure. Our mission is basically to teach as many people possible how to produce their own clean cooking fuel and fertilizer, literally from poop and food waste. So here we use, we have dogs, so we use dog poo. We have food waste, and we don't mean wasted food. We mean residuals from preparing food or residuals from growing food. So the mission really is to educate people so that they can educate others. So we're hoping that this is a economic development project for other areas, for just backyard farming and gardening here in the United States, or really survival skills in remote areas where fuel is just out of reach for so many people now. This replaces LPG gas for at least cooking. So that's part of our mission. So we want to do. The goal is basically 2 biogas education hubs in every state and 2 biogas education hubs in every country who asks us to come and share this technology.
Awesome. Why is biogas an important technology, specifically for addressing climate change and promoting sustainable development? For
me, when we're talking about climate change, I think we're talking, and sustainability, I think we're talking about a really high level, and we're trying to address really big, huge problems, right? So a lot of these problems are being addressed with really large answers. But what we're looking at is small answers to big problems, okay? So if we're talking about every family, having a biodigester in their backyard, being able to take whatever food waste they have and putting it in their biodigester, it never leaves the property. So you're talking about coming from a grassroots perspective. We're talking about coming from the family, where that food never leaves that property. It never ends up on a truck, right? So it never ends up in the landfill. That truck never comes back again to pick it up. As far as economic development, you're talking about you can take this knowledge and do whatever you want with it. See the opportunities. You can start an educational program. You can start a business. You can develop better biodigesters than what we have. You can begin developing. This design can be adjusted for any place in the world. So any place where you can have a tank and plumbing parts to make these inlet, outlet, and gas, you can build these structures. And then you can have service-oriented organizations. You can do this at a community scale as well.
Awesome. So please, can you show us around to...
I'd be happy to. Okay. So the first thing that I do with my food waste is I collect it in a little bin in my kitchen. I do not have my biodigester hooked up to my sink. If I had an incinerator in my sink, like here, we can have incinerators. We have electricity. We can do this. We have indoor plumbing. You know, we can grind this in an incinerator. Mine is outside. We just weren't able to fit it in the basement. My home wasn't designed for that. But we do have people that want to design homes that would incorporate this into them. So what I do is I bring the food waste out. I've got all this recycled stuff from an auction, and I put my food waste in here. So I've turned on my food grinder. It's an incinerator, and it's going to grind all the food waste that I put in here. So you'll see it coming out down there. Now, Rarisu, don't worry if, nobody should worry if they don't have an incinerator or they don't have electricity. All you have to do is actually chop up the food waste really small and then put it into your biodigester. Mm-hmm. This just helps the process move along a little bit faster. And since I have it, I use it. Okay. I'm going to take this, all right, and I'm going to pour it into my biodigester. Okay. All right. Pretty simple. This is my inlet. Can you hear that sound over there?
Yes.
That's the fertilizer coming out.
Okay.
So the microbes inside this tank are going to eat this food, all right? And they're literally going to pass gas. They're going to produce biogas. And then that biogas is going to be pushed up out this hose and into this storage bag. And you heard when I fed this, the fertilizer it's beautifully digested right in about the middle of this tank, and it goes into that storage drum.
So this liquid fertilizer can be used on the farm like regular fertilizers?
Yes, it can. So you've got a really nice NPK value. What we do is we use it for a number of different things. You see, we've got the garden out there. We grow our own food, and I can spread that on that garden any time of the year, during the year. I can also do things like on the lawn. I can use my hose. I can hook on a container. I can put the fertilizer in that container, and then I spray it, and it mixes it down, it waters it down, and I can do the lawn. So it's a natural lawn fertilizer as well. At a large scale, a farm nearby, they use it for their hay field, and they've seen 30% increases over several years.
Okay. So digester doesn't have any use, like they don't have a garden or a lawn to like place this liquid fertilizer in. Is it safe to just throw it down the drain? Mm-hmm. Oh, okay. Yeah, in fact, we live in an area where we don't have public water and we don't have public sewer. So we have a septic system. So we actually put this down our septic tank, and it actually helps to eat up anything that's inside the septic tank as well. So it saves us money because septic tanks have to be emptied every so often, like every few years, depending on the size of your septic tank and how many people you have in the home. So that saves us money because we don't have to have that septic system emptied so often. Okay. How do you use the gas stored here?
Well, I use this to cook with in the house, and I use it on a grill outside. Okay. So would you like to see?
Yeah, sure.
Which one first, the kitchen or the grill?
Probably kitchen.
Yeah, that's what I thought.
Yeah.
Well, this is my kitchen. You can see over there I have an average flat top stove, and we use that in the wintertime when we don't have any gas. Okay, so we keep our regular stove. We've chosen to. And then I have this 2-burner stove that has its own home right over here on the counter. It stays here all year long. But I have biogas about 9 to 10 months out of the year. Okay, so I just have it piped in. It just comes in through our window, and a line runs down behind my things on the counter. And I have a pump over here, and the pump looks really, really complicated because we use it for demonstrations, and I show different options. Like you'll see a line right here. That line actually goes down into the basement. So when I have extra gas, I can store it in the basement.
Oh, nice.
And it's safe enough to store in the basement. So I've got valves on here. I have a pump. So I have electricity, I have a pump, whether you have solar energy or, standard electric energy, you can use an electric pump. There are also solar pumps available that have like onboard charging systems that you can use as well. So I just turn that on. And now I'm ready to heat up and have tea.
Awesome.
Yeah. So you see it's a very clean blue flame. And that's how I use it in the kitchen.
Yeah. In areas where they can't access pumps, be it electric or solar, how do they use the biogas?
I will take you outside and show you.
Oh, okay.
Okay? Thank you. Places where you don't have power or your power is out, what I've done before is I've actually taken a very large, heavy, like a floor mat. It's enough energy to push the gas to my stove. And I can just lay it right across this bag and it'll go to my stove. It's very simple. You don't have to get complicated with really heavy weights because you only need so much weight to push to your stove. If you wanted more weight, just throw on another big mat or some kind of weighted thing that's not going to fall off and hurt anybody. Okay? And now over here, this is a gas holder that it's under maintenance right now. So I don't have any gas in it. You can see it's all the way down, right? So what I have is, if you come right here, this gas holder is hooked up typically to this biodigester right here, and the gas will come in here, right? And I would have this valve closed, so it won't go out yet. And what happens is the gas goes in here through these pipes, and this lifts up. So I can see how much gas I have. So I mark it kind of according to these rails that we've made, okay? So when I want this to, I want pressure on this to push it into the house, and this is way up here. We'll just imagine that it's way up here. I would take these bungee cords. They're just elastic cords. Trucking companies have them. You can get them at hardware stores. These types of things are available around the world. These are really easy to get, and they're very cheap. And all I do is I take these two hooks and I bring it down and I hook it onto the other rails. So say this was up really high, I'd be pulling these nice and tight, and that pressure is pushing down. What other people have done is they've put weights on this, okay? But look at me, look how tall I am or how short I am. I can't be raising weights up here, okay? Or, and I don't really want to leave them on there causing pressure on it all the time. I prefer not to. But it's easy for me to actually pull these cords. I have a bad back, so I can pull these cords and pull them down. So you don't have to be strong. Okay?
Awesome. So, what do we have here?
All right. Well, this is the grill that I use with this gas holder right here. And it's not hooked up to this gas holder right now. Like I said, it's under maintenance right now. But if I really want to use this in emergency, I could either put a weight on this bag, okay, and push it to the grill, which is great. It works. It's no problem. If I wanted to make things even easier for myself and have like lots of flame, I can actually hook up a pump. I can bring my pump out and hook this up, and I can turn that on. So I do have this plugged in right now because we were using it. Okay. So I'm going to open the valves. All I've done is adapted this grill to biogas. And to adapt a grill, you're basically taking the restrictor out of it. Now you can see that flame. It's a good day for seeing the flame. Let me see. So this pump, I like this pump because it has an attenuator on it. We can actually turn this flame down if we want. So we have a little more control. With putting weights on a bag, then you just control it by how much weight you put on the bag and how you place the weight.
Nice.
So you can hear it.
Yeah. It's not so visible from the video, but that's because it's a clear blue flame. You see it's more like we saw it inside because it was darker there. So, but yeah, this is awesome. So typically, how long can you use? First of all, what's the size of?
That's 1 cubic meter, and that's the original bag that Pusheen was making for small-scale biogas practitioners. And then they went to the cube. And one of the reasons they went to the cube was because it would fit inside one of these IBC tank frames. Right? So it would protect it. It wouldn't blow away. You could easily put a weight on it, and just leave it there nice and low. So these are, again, 1 cubic meter.
And how long can you cook on that?
It depends.
Okay.
It depends on what you're cooking and how long you need to cook it. How many burners are you using? So what they're looking at is about 2 to 4 hours of cooking.
Oh, okay. So based on the delivery pressure of the gas.
Right.
Yeah.
Is it on low? Are you simmering or are you boiling?
What's the maximum amount of waste you can put into this system, like the biogas system?
There's a really simple calculation for that. It's 1/40th of the size of the tank itself.
So in terms of volume? Okay.
Right. So what we're doing is this can actually take, I think it's about 6 gallons really of a mixture. You know how I made the slurry? About 6 gallons of that slurry. So food to water, you know, into that every day.
Okay.
You wouldn't want to do any more because we're talking about just like we human beings, we can only eat so much before we get acid indigestion. This is like a stomach and it gets acid indigestion. So you don't want to overfeed it.
Kind of food waste, is it any kind of food waste, or is there a particular mixture of food waste you're meant to put into the system to keep it healthy? And
you want to do like a variety of foods, just like we eat. We eat a variety. We eat a multifaceted diet.
Okay.
So you've got your fruits and your vegetables. You wouldn't want too much citrus. You wouldn't eat too much citrus because that would be way too acid. We want to go all the way up to, you know, bread and potatoes and, you know, potato peels, carrot peels, all the way up to even fats. Like I have jars of grease for my cooking and I have too much of it. So what I'll do is if I have, say, some flour that went bad, I would mix that with the flour and then I could feed that. So it's really like the amount of gas that's produced goes up to fats. So it produces even more with the fats.
So is there like an optimum pH that this digester works out at?
Well, you're going to ask me a tough question. You know that I've had this now for, this is 9 years old. And I used to do the pH on them. I'm guessing 6.5. But I've had them for so long that I stopped testing the pH because there wasn't any need for it once you start. It's kind of like I equate this, you know, as a practitioner, because I'm a mama, I'm not a scientist, okay? Yeah. I'm just using this every day. I equate it to baking bread. You know, it takes practice and you usually learn it from somebody else and you're not really concerned about the science of it. You know, there's a chemical reaction that goes on with bread, but most people don't even know what that chemical reaction is.
Yeah.
So I'm more from the bread baking area, you know, and less the science. I'm surrounded by the science, so I guess I kind of like let that drift away and really talk about more like the smell. Like if the fertilizer smells sour, you know there's something wrong. So, you know, I compensate that way.
Smell.
It should have an earthy smell.
Oh, okay.
Yeah.
Okay.
Yeah. And if it does like bother your nose, it's there's something not quite right.
Okay. So when we're inside your kitchen, you talked about it not being able to work during winter period.
Yeah.
So what's the right temperature, or at what temperature does it stop working?
Well, that's really interesting because, you know, I read research on what temperature and everything, and it seemed pretty high to me. And the funny thing is when your biodigester is a baby, it's more sensitive to the temperature. And it seems like over the years, this is actually acclimated to where it lives. So the first year it was like, I was without gas for 3.5 months. And then it was a few years later, it's 3 months. And then it's down to 2.5 months. So really, I'm starting to get gas as soon as the sun starts shining in the spring on that. And I've got really about 50 degrees Fahrenheit weather. I'm starting to get gas, which is, to me, that's amazing because the numbers are much, much higher. It's more like 68, 80, you know, 80 to 100, you know, all of the higher temperatures, like your optimum. And you can see we have a lot of biogas, right? So it's kind of like a bell curve. So you've got the warmer the weather gets, the more you're producing the gas. And when you get up to 80, 90, 100 degrees, you know, you're at a peak level where you're really producing a lot of gas. And then, you know, the fall starts to come and it starts ramping down. So for me, I see it as it's going to be different for everybody depending on where they are. And that's one of the things we're working on.
So in your experience, what are the main benefits of using biogas compared to other renewable energy sources?
It's free. It's free.
True.
We have, okay, the other benefit is we have all of the resources for it. We all have poop and food waste, right?
Yeah.
Whether it's human or dog or cow or, we all have that.
So, but can you tell us some challenges you face, especially in small scale biogas system?
It depends on where you are. Like here, we're really lucky that we're supported by like our Chester County leadership, by our township. A lot of people here are going green, as far as, doing their best to conserve energy through alternative sources. So we have a lot of support here. So I think one of the challenges is that people are afraid of it because it's gas. You say the word gas and they're scared. This is actually safer than LPG because it's not going to explode on you in your face. You saw when I lit the stove, it's not, it's not scary. So I think that's one of the challenges. Another challenge is we haven't gotten to a point where we can make it small enough to fit in a kitchen. And I think in order to make it small enough to fit in a kitchen or in a basement, we have to create optimum conditions. Okay, so we need the right temperature, we need the grinding because that would be optimum. We need all of the perfect, situations for this. So that's one of them. And then here in the Northeast, the biggest challenge is the winter weather. This is outside. I don't have mine indoors, but I want to use it year round. So the biggest challenge for us here in the Northeast is actually temperature control or thermal controls. So we want to keep this baby, warm throughout the winter.
So can you tell us why this is coated and what is it coated with?
Well, one of the solutions that a friend of ours thought about, because he's in the foam industry and he uses a soy-based foam, he wanted to test to see if we could insulate it, this system more simply with foam to see if we could extend the life of the biodigester. And it did lengthen the time that we could use it. What we did was basically we took that basic design right there, we wrapped it in some fabric, and then foamed it. So you had a little bit of an air gap, around it. And that first year, we definitely got, a little extended season. And then T.H. Colhane came down here from New York, and we played. We decided to put in a couple of used windows to get a little bit of passive solar gain. So we put, the sun rises here, and then it sets over there. So we basically put the windows in a location where the sun would hit it all day long. So we've got one here and here. And that has extended the season. So this one is only asleep for maybe 2 months.
Okay.
Yeah, so it really comes back.
Awesome.
And it's not even asleep, it's still creating a little bit of fuel.
Oh, fuel.
Yeah, it's amazing. It depends on how sunny the winter is because you've got that passive solar gain.
Can governments and organizations and individuals support the widespread adoption of small-scale biogas production? Are there any policies that should be put in place or financial barriers that needs to be addressed?
Yeah, actually right now there are policies being worked on in New York State, New Jersey, and Pennsylvania. What they're working on is taking the regulations for biogas in general. We're taking that out of large scale, because when people say biogas, when it comes to policies, they think large scale biogas. Okay, so this is backyard biogas basically. It's very simple. So they're working on policies to actually remove the small scale out from under the large scale biogas policies. So there's a clear, clear instructions.
Okay. Awesome. So can you share any inspiring stories or examples of how biogas projects actively impacted like local communities, especially in terms of social, economic, and environmental aspects?
Sure. There's a farm nearby. It's called Windy Hill Farm. And that was actually where we put the first 10 cubic meter pushing digester. It's like a concrete septic system, but it has a dome in place to collect the biogas. What happened there was really unexpected. We helped them to keep records on how many bales of hay that they were producing every year. So we took a baseline the first year. Then at the end of that year, the farmer there fertilized it with his biodigestate. The whole field, left the other field alone. So the next year, what happened is they actually had a 30% increase in their amount of hay. Now, this is a family who had, at the time, I believe 6 cows, and they would always have to buy hay. I mean, they produced enough, but they needed just a little bit more. So they were always buying hay. Now, this is a multi-generational family on the same property for hundreds of years, all right? They always had to buy hay because they didn't have enough field. So what happened is they put some more fertilizer on that second year. And the next year, we were really surprised because they had another 30% increase over that year.
Oh, wow.
It was, yeah, oh, wow. And then that year, what they decided to do is they decided not to put anything on it that year to see what happened. And the next year, they had another 30% increase. And those last 2 years, they had to find a way to sell hay. So there is a huge economic change. They didn't have to buy any hay for their cows.
Probably a key material in regenerative agriculture.
That was it.
Yeah.
They were regenerating the soil.
Yeah.
Because it increased again 30%. And then on the fertilizer side, they had a lot of fertilizer, so they would store it in tanks, and they would use it on their field, but then they had extra fertilizer, so they started selling it to a farmer in Lancaster County. The model of a biodigester that we used in our TED Talk, which was called Home Scale Biodigester.
Awesome.
So we did a TED Talk. So that was fun.
Yeah.
It's very, very simple. We really felt that people needed to see the inside to get a good idea of what was inside. So you can see our model like you saw in the biodigesters over there. We have our feed inlet, right? We have our fertilizer outlet, and we have our gas outlet. So on the inside, what we did was we wanted you to be able to see the inside. So if you see the feed inlet, we've got about an 8-inch cut in there so that the food waste can actually fall into the chamber nicely, okay, smoothly. And then that hole right there on the fertilizer outlet is actually where that pipe actually takes that fertilizer out. So it comes from the middle of the tank. So when we first start building a biodigester, we want to put we put stones in ours. Okay. You need some kind of surface area for the microbes to live on. So you can do stones, you can do lava rock, you can do biochar, you can do a lot of things in here. You can take some recycled material and weight it down. If it floats, you want it to go down to the bottom. So most of your microbes live down here in that housing development here, okay? So when you put the manure in, a lot of people are confused. They think they have to fill the tank with manure. You don't. You're just inoculating it with manure. So you want some fresh manure, cow manure, horse, pig, and you really only need about this much.
Of manure?
Yeah, of manure, yeah. And then the rest of the tank, you just fill it up with water. And then you let it ferment.
Okay.
So
in terms of volume, so these are 1,000 liters,
275 gallons.
Okay.
About that much.
So
we don't like to
one
measure.
Bucket, 2 buckets.
Yeah, I would say that's probably about 4 buckets of manure.
Oh, okay.
And before we close it up, we actually, let me take this off. The easiest way to get the manure in here is through the largest orifice, the largest opening. So what I've done is I've just taken like a tarp and kind of put it down and around here so it doesn't get all messy.
Yeah.
I actually, you can put the manure in we've had people just dig their hands in and put manure in. We've had people mix it up and pour it in.
Yeah. Okay.
Yeah.
Awesome.
Just get it in there. And, we've, 4 or 5, I think when we really wanted to supercharge a biodigester that we started in February, I think we had 1, 2, 3, 4, 5, we had 7 buckets of manure that we then mixed with water, warm water, because we were starting it in the cold weather.
Would there be anything like too much manure?
Yeah.
Really?
Yeah. Yeah, definitely. So really, you only want, maybe about this much manure.
Yeah. Okay.
That's all you need. You don't want to overdo it when you're first starting it. It's just too much. Okay. We've had people actually fill it up to the top, wow. And then,
it's messed up.
The biogas, the microbes need
water.
They need space. They need water. They need room. So they need room for the gas to actually bubble up. So if you have too much in here in the beginning, it's just going to form like a deep, compact sludge, just like in the bottom of a lake or something.
So Janice, what advice would you give to someone watching this video now and that is interested in starting their own small-scale biogas system anywhere in the world?
I would suggest, if they have access to the internet, that they do some research. We have a YouTube channel, and it's just youtube.com/SolarCITIES. That's where we put up our most important instructions and up-to-date instructions. And they can come to SolarCITIES.solutions on the web, and they can go through some of the projects on there. We also have a book available online. It's just $9.99 if they want to download it. It's a downloadable PDF, but if they're in a place where they really cannot afford $9.99, they just have to email us and let me know. Okay, we'll make it happen. But the best advice I can give is don't be afraid. I've built a lot of these, and I'm not a scientist. I'm not an engineer. I'm not young, and I'm not tall.
Yeah. So what about the Facebook group?
Facebook group. Yeah. The Facebook group is great because we've got hundreds of people. There's about 15,000 members, but there are hundreds of people there who are really contributing and helping other people get started. And that's on Facebook at SolarCITIES Biogas Innoventors and Practitioners. Yeah.
So I'll be leaving like the exact name in the show notes, the link to the website, everything will be on the show notes. Janice's LinkedIn, in case you need to reach out to her directly, I'll leave everything there. So thank you very much, Janice,
for
taking us through like the SolarCITIES Biogas Digesters, and thank you for accepting me into your home for like 2 days. Thank you so much. And
you're welcome.
Yeah, guys, thank you for listening and watching. Remember to subscribe and follow us anywhere you listen to your podcast, and I'll see you in our next episode. Bye.
Bye.
Thanks so much for listening to the Sustainability Nuggets podcast. I am Rarsu Maribi.
And I am Tosin Folorunsho. If you enjoyed this podcast, please leave a rating and review on wherever you listen to your podcast.
You can also show your support by signing up for a small donation to help sustain future episodes. You can find all relevant links in the description. See you in our next episode.